This is Calc 2, Exam 4 solutions. Number 1, asked to go from negative pi to pi. So I made a little table, negative pi over 2, 0, pi over 2 pi. X is t squared, so it's pi squared over 4, 0, pi squared over 4, pi squared, which is about 9.9, roughly 10, 2.5. And y is 2 sine of t, sine of negative pi is 0, sine of 0 is 0, sine of pi is 0, sine of negative pi over 2 is negative 1, times 2 is negative 2, sine of pi over 2 is 1, times 2 is 2. So we go from roughly 10, 0 to 2.5, negative 2, 0, 0, 2.5, 2, and then back to where we started from, way over here at 10, 0. Number 2, y equals 1 over sine of t, which is 1 over x, so y equals 1 over x. But we're only going from 0 to pi over 2. If I plug in a number slightly bigger than 0, like 0.001, sine of 0.001 is about 0. That's the x coordinate. Therefore, the reciprocal is super big. At pi over 2, sine of pi over 2 is 1, whose reciprocal is 1. So we're starting way up here, going in this direction toward 1, 1. Number 3, at t equals 1, the ordered pair is 1, 2. dy dx is dy dt over dx dt, 2t plus 3 over 2t, which is 1 plus 3 over 2t. Plug in 1, dy dx is 1 plus 3 over 2, 5 over 2. Y minus y1, y minus 2 equals m, 5 over 2, x minus 1. 4, dy dx is negative 4 sine t over 3 cosine t, which is negative 4/3 tan t. D squared y over dx squared is a derivative of this with respect to t, which is negative 4/3 secant squared t divided by dx dt. Just copy this, negative 4/9 secant cubed. Number 5, the polar graph paper. So r equals 1 plus 2 cosine theta. The maximum r is 3, which is 15 circles. R equals 1 is 5 circles. Therefore, r equals 0.2 is any one circle. So r equals 1, 2, and 3. Okay, little table here. Plug in 0, cosine of 0 is 1, times 2 is 2, plus 1 is 3. So both of these are 3. Halfway, plug in pi. Cosine of pi is negative 1, times 2 is negative 2, plus 1 is negative 1. Cut that in half. Pi over 2, cosine of pi over 2 is 0, plus 1 is 1. Same reason, this is also 1. And cut that in half. Pi over 4, cosine of pi over 4 is radical 2 over 2, multiplied by 2, it's 1 plus radical 2, 2.4. Okay, over here, this would be negative radical 2 over 2, so it's 1 minus radical 2, negative 0.4, negative 0.4, 2.4. Okay, so at theta equals 0, we're at the maximum of 3, way over here. And then for the 45-degree marks after that, it goes 2.41, 2.41, and then negative 0.4, negative 1. I do want to know when it comes into the pole. So I solve 1 plus 2 cosine theta is 2. Cosine theta is negative 1/2. That means x coordinate is negative 1/2. That's there and there. That's 2 pi over 3 and 4 pi over 3. So when it reaches 2 pi over 3, comes into the pole, then comes out at 3 pi over 4 to negative 0.4. And then at pi, I'm at negative 1. So I'm heading this way, but I back up. And then continue on to 5 pi over 4, negative 0.4. Come back into the pole at 4 pi over 3. And by the time I reach 3 pi over 2, I'm coming back out to 1. And then 7 pi over 4, I'm back to 2.4, and then back where I started, way over here. So here's the graph. Here's the analysis at the top, and here's the table. Number 6, one loop. So I just need to draw one loop. If I plug in 0, I get 2 times 1 is 2. At pi over 6, I'm taking the cosine of pi over 2, which is 0. So it comes into the pole at pi over 6. So I decided to back up and go negative pi over 6. It also comes into the pole. So here's one loop, from negative pi over 6 to pi over 6. I will integrate from 0 to pi over 6 and double the answer, which fortunately means the 2 and a half cancel each other out. 2 cosine 3 theta squared. That comes out to be 4 cosine squared 3 theta, which is 4 times 1 plus cosine 6 theta over 2. Take out the 2 with the 4, so 2 parentheses theta plus 1/6 sine of 6 theta. Plug in 0, you get 0. Plug in pi over 6, this is 0. You're taking the sine of pi. So we only have pi over 6, 2 pi over 6, or pi over 3. 7, where do the graphs touch? Does this ever come into the pole? Yes. When theta is 0. Does this come into the pole? Yes. Theta is pi over 2, so they touch at the pole. Then set them equal. Divide both sides by 2 cosine theta. Tangent theta is 1. That's in quadrants 1 and 3. Pi over 4, 5 pi over 4. Plug in pi over 4. Sine of pi over 4 is radical 2 over 2. Multiply that by 2, I have radical 2. Radical 2 comma pi over 4. At 5 pi over 4, I get negative radical 2, but these represent the same point. They are 180 degrees or pi radians off from each other, and the r's have the same magnitude. So these are the same point. So I only have to write this one and the pole. So final answer, pole and radical 2 pi over 4. Number 8, with the vertex of the origin, I have to form y squared equals negative 4px. So p is 2, opening to the left, but shifted 2 right and 1 down. So I go 2 right, 1 down. The vertex is 2, negative 1. The p is 2. So the focus is at 0, negative 1. Directress is x equals 4, and the graph looks something like this. Number 9, divide both sides by 225. X squared over 25 plus y squared over 9 equals 1. A is 5, b is 3. A squared equals b plus b squared plus c squared. 25 equals 9 plus c squared. 16 is c squared, so c is 4. That's a focal distance. So vertices are at negative 5, 0, and 5, 0. Foci at negative 4, 0, and 4, 0. These points, which don't have any special name, are at 0, 3, and 0, negative 3. And number 10, C is 8, A is 6. Vertices are plus or minus 6, 0, and foci are plus or minus 8, 0. So C is 8, A is 6. I know it's going this way, so x comes first. C squared equals a squared plus b squared. 64 equals 36 plus b squared. So b squared is 28. So the equation is x squared over 36 minus, that's a minus, y squared over 28 equals 1. All right, so these are solutions to Calc 2 exam number 4.